Hello everyone. Well, here is today's challenge. A rope is wrapped around the earth. 1 meter is added to the length. Calculate the gap. So the gap we're looking at is the gap between the surface of the earth and the rope. So before we get going on this problem, you might just want to reflect on it a little bit. So we've got a rope wrapped around the surface of the earth. We're going to add 1 meter, just 1 meter to the length of the rope. So the earth is sizable, and you're going to add just 1 meter to that length. Then we're going to pull the rope, hypothetically, away from the surface of the earth, and there will be some gap. Now, how big do you think that gap is? Do you think it's big enough to slide a pencil through? So just reflect and see what you think in your mind, how big that gap might be. We are also going to model the situation by making some assumptions. So you might want to think about what those assumptions are. So at this point of the video, I recommend you pause it and have a think about the problem yourself and see if you can come up with an answer for the distance of the gap between the surface of the earth and the rope. Okay, so let's look at the problem in a bit more detail here. Now, one of the assumptions we are going to have to make is that the earth can be modelled as a sphere. So the cross-section will look like a circle. And we know the circumference of a circle is 2 pi times the radius. Okay, so now we look at the situation. What happens when we add a meter to that rope? So C here was the length of the original rope. We're going to add a meter to it. So I've converted that into centimeters. That just makes the calculation a bit easier later on. And that new circle is this red one here. The circumference of this red circle is 2 pi times the new radius, so 2 pi times r plus g, where r is the radius of the earth and g is the gap. Okay, so we now have two equations. I'm going to call this one equation 1 and this one equation 2. Now let's sub in equation 1 into equation 2. So C plus 100 equals 2 pi r plus g becomes 2 pi r plus 100 equals 2 pi bracket r plus g. Okay, and then expanding the brackets on the right hand side, we get 2 pi r plus 2 pi g. Okay, and next comes this magical step where the 2 pi r's cancel out. And we are left with 100 equals 2 pi g. Now the thing to note here is there's no r, there's no radius in this equation. So that means the result is completely independent of the size of the circle or the size of the globe that we are talking about. Dividing both sides by the 2 pi gives us an equation for g. G is 100 divided by 2 pi. And calculating that on a calculator gives you an answer of around about 15.9 centimeters. Wow, that's massive, is it not? We added a meter onto this rope. It was wrapped around the surface of the earth. We added a meter to it, just 1 meter. And then we pulled it away from the surface of the earth. And the gap between the surface of the earth and the rope is 15.9 centimeters. Now this result is independent of the size of the circle we are talking about. So you could try it on a football. Put a rope, a piece of string around a football, add a meter to the length of the string and pull it away, and you'll get 15.9 centimeters. You could try it on a golf ball or even a snooker ball. So I offer you that challenge to have a go at seeing if the result works for different size circles. Okay, thank you for joining. My name is Phil, And if you're looking for an online maths tutor, you can contact me on 360maths.co.uk. Goodbye.